Hello folks, in this video we're going to take a look at naming aromatic hydrocarbons. Okay, now what is an aromatic hydrocarbon? Well, this here is the skeletal structure of an aromatic hydrocarbon. And what does that mean? This is 6 carbon atoms. Remember, each one of these points is a carbon atom. And here we have these double bonds. Okay, so there's 3 double bonds. This is a cyclohexatriene, all right? Now, we know chemists are lazy. Organic chemists are even lazier. And it's like, could we draw this any lazier than this without showing all the hydrogens in the carbon atoms? Yes, yes, we can. We can be even lazier. And so what chemists will do is they'll say, okay, these double bonds, this is a resonance structure. And you might have to go back to a previous chemistry class, but resonance structures just means that these double bonds here, these electrons are delocalized. That is to say that they're not really here. They're here, 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 here. They're all over the place. They're moving. They're constantly moving around. And so rather than drawing it like this, organic chemists will often draw this molecule like this, okay, with a circle inside of it. And that's just showing now that these double bonds are resonating. Those electrons are delocalized. They're moving all over the place. Okay, so this right here is what we would call a benzene ring. Okay, so I'm gonna label this here benzene. B-E-N-Z-E-N-E. Okay, and this benzene ring is aromatic. And what aromatic means is you can smell it, right? Like, whoa, oh, should stop sniffing markers. Okay. So a benzene ring or an aromatic molecule means it's smellable. That's all aromatic means. It just means you can smell it. All right, so this is the basic structure. It's benzene. And we have some different forms of this. Like if we were to have a chlorine atom on here like this, like that, it becomes chlorobenzene, okay? Or if we have a fluorine atom on here like this, then it becomes, I should go like this, okay, like this. All right, if we have a fluorine group on there, it becomes fluorobenzene, okay? So just different types of benzene. There's another one here, and that would have a CH3 on it, like this, CH3, like this. And this has a fancy name here. We don't call it methylbenzene, because why? I don't know. This is just people a long time ago just decided to come up with these things and the name stuck. So this one's called toluene. Toluene. And you might recognize toluene. This is the stuff that is in fingernail polish. It's the solvent in fingernail polish. So you ever smell fingernail polish and it kind of makes you a little loopy and stuff, or you walk into like the fingernail polish salon, right? And you're like, oh my gosh, wow, what's that smell? That's toluene, okay, toluene. It's an organic solvent, and it's not good for you. It's not good for you. But anyway, so that's the fancy name for that one there, is toluene. Okay, and then if we were to take the benzene ring and we were just to attach it to something. And so what I'm going to do here is I'm going to say that this right here is not a methyl group coming off of it, but it's just being attached to something. So what I'm going to do is I'm going to go like this. I'm just going to go a little zigzaggy line like this. That just says that it's attaching that benzene to something. Then it becomes a fancy name here. It becomes phenyl. Phenyl, a fancy name. It's just a benzene ring then attached onto something. Okay. Now, some other things with naming these aromatics is the position of where things are attached. So sometimes we will have things attached here and here like this. So I'm just going to go, stuff is attached like that. It could be attached like this and like this. Okay, so like in the 12 o'clock and then like 5 o'clock position. And then on the opposite sides like this. So I'm just going to go opposite sides like this. Okay, and these have names for them. Okay, benzene rings like that. Okay, so the names for this now, if they are in this position like this, if they're in this position like this, we call this the ortho position. Ortho position, that is to say that they're next to each other on the benzene ring. Now, if they're like an extra carbon between them like this, where they're spread out a little bit like this is called the meta position. Meta position. And then if they're on complete opposite sides like this is called para. The para position. So how do we, let's do an example of this, okay? So instead of X, right? So some of you maybe are looking for X on your periodic table, and there's no element X, right? I mean, there's xenon, right? But there's no X. So I'm just gonna go like this, and then let's put chlorine in here. Chlorine, like this, okay? Chlorine, like this, and then chlorine, like this. Okay, chlorine, that's an element. All right, so now how do we name this one here, okay? So one way of naming this is you might say, oh, well, if I were to just number these things, right, here's 1, and then here's 2, right? And here's 1, 2, 3, and here's 1, 2, 3, 4. But wait, what if you went the other way? 1, 2, 3. It's the same thing. Okay. So you might think, well, let's just call this one 1, 2 dichlorobenzene. 1, 2 dichlorobenzene. And you'd be right. Okay. So this would be 1, 2 dichloro. Chlorobenzene. Okay, 1, 2 dichlorobenzene. That would be correct. But you see, some of these molecules got named a long time ago and the name stuck. So there's another name for this molecule. The other name for this molecule here is ortho dichlorobenzene. Okay, and both of these names would be correct. This 1, 2 dichlorobenzene, that's like the more modern name. And then this here is the name from the olden days that just kind of stuck and some people are still using. Okay, so this one here would be meta dichlorobenzene, and this would be para dichlorobenzene. All right, or you could say 1, 3 dichlorobenzene or 1, 4 dichlorobenzene. Okay, all of those names would still be correct. All right, so that's just some naming, some simple naming of aromatic hydrocarbons.